In this problem, we have Wile shooting himself at a stationary cart, causing a collision, and after the collision, Wile flies off at a 21-degree angle and the cart flies off at a 10-degree angle. And so these are our givens, and we need to find the final velocity of Wile and the final velocity of the cart. So we know that the momentum of Wile in the final x direction plus the momentum of the cart in the final x direction is equal to the momentum of Wile initial x direction plus the momentum of the cart initial x direction. So if we substitute momentum for mass times velocity, then we have to do the mass of Wile times the velocity of Wile final and times cosine of theta of Wile plus the mass of the cart times the velocity of the cart final cosine theta of the cart equals the mass of Wile times the velocity of Wile initial plus 0 since the cart is at rest. So then we can cancel the masses, which gives us this equation. Then we know that this equals 0 in the y direction, so therefore we can solve for the velocity of the cart and the final in terms of the final velocity of Wile. So once we plug in mass times velocity for each of these, we can solve for the velocity of the cart final is equal to 1.474 times the velocity of Wile final. So then we can come down here and plug those. We could take this value and plug it into this equation, which gives us this. We have the final velocity of Wile times cosine of theta of Wile plus the mass of the cart times 1.474 times the velocity of final Wile times the cosine of theta of the cart equals the velocity of Wile initial. So we plug in our values and then solve for the velocity of Wile final, which gives us a value of 0.637 meters per second. And then we just have to take this value and plug it back into this, which gives us the cart's final velocity as 0.939 meters per second.